Hi, welcome back to Algebra 2 and the beginning of Unit 2. The first few lessons in Unit 2 really have to do with operations on polynomials, and although some of it might seem so elementary to some of you, they are um, tasks that really need to be mastered before we can really move on to some more of the complicated problems that we do in Algebra 2. So hopefully the first few lessons are going to go really easily for you. And if they don't, it's a really good opportunity for you to really make sure that you've mastered them before we move on. All right, so here we are in exercise 1. I know you think you're in first grade, but we have 2 apples plus 3 apples equals 5 apples. All right, so it's kind of the same thing when we're adding like terms. So when you consider x's, you consider here we have 4x's plus 3x's is equal to 7x's. All right, so it's just like those apples. Physically, you've got 4x's in your hand, plus you add 3 more x's in your hand, and now we've got 7x's in our hand. All right, so the 4 and the 3 and the 7, these are all called coefficients. The vocabulary is important so you understand what I'm saying. And of course, x in these cases is the variable. Okay, so note, we can only add them together if they're exactly the same. I used to tell my Algebra 1 students, if they have the same last name, we can add them together. So if you consider adding, 2x plus 8x, well, the 2 and the 8 have the same last name, so we can say that's 10x. But if you say 2x squared plus 6x, now they might be related. They could be cousins, but they're not exactly the same. All right, so in this case, you cannot add those like terms together, and you just leave them as 2x squared plus 6x. Okay, so I put an example here is the same thing. 4x plus 5x squared cannot be combined together. They're related, but they're not exactly the same. All right, so a couple of little exercises here. Exercise 2, if we look at these two, let's get that line out of the way. Can I get that line out of the way? Maybe not. All right, so combining like terms. I think the easiest way to do this is just by, and sometimes we don't have different colors. I have different colors here, so I can do this, but maybe if I do it in the same color and just change my shapes. So my like terms, notice when I circle them, I take the sign in the front. There is no sign in the front here, so you can add a plus 1. So 1x squared plus 6x squared is 7x squared. Then I move to the x's. Notice how I'm doing this in descending order, because this is the way in mathematics we generally write things. So I start with the highest degree, or the highest exponent, which is the x squared. I move to the x's, so positive 2 and a minus 7 is a minus 5x. And then last I have negative 6 plus 8, which is a positive 2. Once again, some of you might be saying, I can't believe we're doing this really easy stuff. Well, my advice is enjoy it while we're doing it. So again, we're going to start with the highest degree, which is 3 this time. So we have 3b to the third power minus 5b to the third power, which is minus 2b cubed. Excuse me. Now we move to, oh, that was a mistake. We're going to move to the, let's get rid of this here. We're going to move to the positive 2b squared, and I have nothing that combines with that. So that's going to be all by itself. Just like with this one, nothing combines with it. So minus 8b to the first, technically. And then lastly, we have positive 1 minus 3, which is minus 2. All right, so beware of that. There isn't always something to be combined. Okay, now moving on to exercise 3. We're going to be multiplying algebraic expressions here. We're going to start with monomials, which are one term terms, one-term terms. So there's nothing in between that's adding or subtracting, so they're being all multiplied together. So it says, when you're asked 2 times 3, think about what it means. 2 times 3 is just repeated addition. So it's 2 plus 2 plus 2 3 times is equal to 6. So if you keep that in mind, when you multiply monomials, you multiply the coefficients and then you multiply the variables. So we do 5 times 2x is 10, and then throw the x on the back. B, 3 times 5 is 15, throw the x squared on the back. 6 times 9 is 54. Now beware here, because now we have x to the first and x to the third power. Going back to our laws of exponents, we keep the base, we add the exponents. 4 times 8 is 32. We have n to the sixth and n to the third, which is n to the ninth. I just did them really fast. If you need to pause, make sure you are pausing to write things down. Moving on to E. 9r times 3r is 27r to the second power. Remember, there are little ones hiding here that you can't see. Now, when we get to F, we have two different variables here. So 12 times 2 is 24. And because the W and the Y are by themselves, basically in mathematics, we make sure that we put them in alphabetical order. It makes things a little bit easier. All right, so 24 WY. All right, don't panic. Geez, not so bad. Do the coefficients first. 15 times negative 2 is negative 30. And now we have an A, a B, and a C. So A, we have a to the fourth, a to the third, add them together, a to the seventh. B, don't forget about the 1 that's here, so B to the seventh. And C, there's a 1 here, C to the third. Take it step by step. And H, 6 times negative 3 is negative 18, and negative 18 times 4, negative 72. M, we're going to put in alphabetical order again. So M to the sixth, N to the sixth. All right, so hopefully this is not new to you, nor is it too scary. So we are going to move on to exercise 4. And we're just going to do some quick vocabulary here. Expressions versus equations versus inequalities. So expressions. An algebraic expression is a mathematical phrase that can contain ordinary numbers, variables like x or y, and operators like adding, subtracting, multiplying, and dividing. It has no comparison signs, nothing equal, nothing less than, nothing greater than. So some examples might be 2a, 3x over 2, 4x squared plus x over 2, 3x squared plus 2x minus 4, and simply just an x. Notice how there's nothing here comparing it to anything else. These are expressions. Equations. Equations are going to have equal signs. We have the word equal embedded right inside of here. Equal signs. So now I have 3x equals 9. It's something that can be solved. X plus 1 equals 10, and x squared plus 2x plus 1 equals 0. So these are all examples of equations. Now, inequalities. Surprisingly enough, we don't deal a lot with inequalities in Algebra 2, but just because it just follows suit, we thought it would be a good idea to put them down. So anytime you're going to have something less than or greater than something, x plus 1 is greater than or equal to 10, and x squared plus 2x plus 1, let's say, is greater than 0. And then quickly, we have a couple more vocabulary words. Again, these are all from Algebra 1. Moving on. A monomial is an expression consisting of one term. So something that looks like 3x, 2y, 4ab, negative 5x squared y, or something like x squared y cubed divided by 5. These are all monomials. A binomial is an algebraic expression consisting of two terms. So binomials, things like x plus 1, like x squared minus 9. These are binomials. And of course, a trinomial consists of three terms. And usually we're used to seeing them that look something like this. Notice these are all expressions. I am not comparing anything. And usually we call something these are all polynomials as soon as you have more than one. But when you have things that look like 3x to the 5th minus 2x to the 4th plus x cubed minus 2x squared minus 3x plus 9. Instead of calling it a quinomial, we just call it a polynomial. All right, so we talked about this a little bit before too. The degree of a polynomial is the highest exponent that's represented inside the polynomial, inside the with the highest exponent of each variable. So we usually refer to the degree of a polynomial or equation consisting of the same variable with different exponents. So for an example, we talked about what degree 1 looks like 3x. Degree 2 would be something like 5x squared. Now I'm using monomials as examples here. Degree 3 would be negative 4x to the 3rd power, and you can even have several other terms after it, but the highest exponent is going to be your degree. So how about degree 6? What would that look like? That might look like something negative 2x to the 6th power minus 2x to the 5th power plus 5x to the 4th power, and so on. So as long as this polynomial has degree 6 because it has the 6 as the largest exponent. All right, well, that was pretty easy. That's 2.1 in a nutshell. So exercise 2.1, independent practice. Guys, you don't have to wait for this to be done in class. I seriously think you can try this at home. All right, because I don't think you need people to help you. Although when we come back, you can use your people to check your answers. All right, so give it a try and go on to 2.2 because it's not so bad either.